part of Group Bravo, where our project is Antarctic Chasm 1, and we're thinking, how should we start this presentation and, to break the ice, right? We'll start with a problem. So basically, the British Antarctic Survey approached us because they have this station called the Halley Research Station that is on the Brunt Ice Shelf, basically in the Antarctic. It is right here, right now, and it's dangerously close to this chasm, Chasm 1, all right? Maybe 6 kilometers away from it right now. And there's some other chasms that have been growing, very steadily in the past couple of years. And basically what that means is that they have all this data collected at different time points from different sources, basically. But it is very difficult for all of it to come together and to make sure that, it's understandable why they take the decisions that they take and all that, especially as they're trying to talk to the public, the scientists that have all that experience know what's going on in their head, but that's, not very useful if you haven't had 20 years of experience with that data, right? So our mission, and this is, by the way, how big the Chasm 1 is. So our mission was to build a visualizer of that crack and of the Brunt Ice Shelf, and basically Matt will tell you a bit more of how that was built.
So, as Val mentioned, we have a wide variety of input data from satellite imagery. We could have got hold of, we're aiming to get hold of ground-penetrating radar data and drone data as well. And so we structured our project in terms of a pipeline going from the input stage through to storing the data in a way that we could make use of, and then passing that through to things that the user actually wants to see in here with the renderer and audio. So the preprocessor takes in a wide amount of data. Is designed to enable us to take in a wide amount of data, whether that's elevation data or imagery data and things like that. And it breaks it into tiles that are more manageable for the renderer, compresses it and stores it in our database. The database was built using Postgres and PostGIS, which makes it pretty much trivial to query for the image data that we need within a certain area. So we can quite easily say, here's an area around the chasm, and find out all of the imagery that we have around that area. And then the renderer works by loading in that data that we've stored in the database, decompressing it, and making sure that it's rendered in a way that looks realistic to the user, or at least believable to the user. It was built using C++ and OpenSceneGraph, which both presented their own set of challenges, as I'm sure anyone who's used either of them is familiar. And together, that enables us to produce imagery like this.
It looks like the moon, but it's not the moon. This is actually the Antarctic.
And you can also see how you get sort of discontinuities in the data due to satellite imagery, which is one of the notable challenges of the particular data sources we have. Some more that look a little bit more interesting. And so you can just about start to make out the chasm here. And as the project went on, we gradually got slightly more interesting renders of the chasm itself. And so, as we mentioned, there were a few challenges along the way. Most notably, perhaps, was the fact that the scientists that we were supposed to be working with at BAS were just as excited about the project as, well, sorry, not about the project, but about the chasms themselves, partly because they're having to move to the station, and so a lot of them are completely on the opposite side of the world, and so getting hold of data was obviously a bit challenging. You can also see that some of the data is a little bit incomplete or a little bit challenging. So you can see here that we've got the raw input data in our render, and making sure that this sort of jagged edge doesn't affect the image is quite difficult. And so to wrap up, we learned a lot about dealing with geographic data as the geologists and geographers at the BAS would be very familiar with, but we're not necessarily familiar with. And on that note, dealing with clients with very specialized knowledge that's very different to ours was perhaps the most unique challenge of this project. So yeah, finally, thanks to